Let's look at prime factorization. We're going to start with a quick review of vocabulary. When you find the factors of a number, you are finding the numbers that divide evenly into that number. So let's look at 24 as an example. 24 can be thought of as 1 times 24, 2 times 12, 3 times 8, and 4 times 6. When we do prime factorization, we're finding out which prime numbers, when they're multiplied together, will give me 24. Remember, a prime is a number that has only two factors, 1 and itself. So again, let's look at 24. So I'm going to start by thinking of 24 as 3 times 8. And what we're going to do is we're going to create a factor tree. This is a diagram that will make it easier to tell when we've found all the primes that go into the number. I'm going to put 24 at the top, and branching off that are the two factors, 3 and 8. 3 is prime, so I'm going to go ahead and circle that. Now I'm going to branch off the 8 and find its factors, which are 2 and 4. Again, 2 is prime, so I'm going to be circling that. And 4 is 2 times 2. And since those are both prime, I'll circle those. So, if I was going to list the prime factorization of 24, I would write 2 times 2 times 2 times 3. Usually when we write it, we write from the smallest number to the largest number. Often, it's easier when you have a lot of numbers repeated to put it into exponential notation. And since there are 3 2's being multiplied together, we say that's 2 to the third power. And we would write this as 2 to the third power times 3. So would I have gotten a different answer if instead of using 3 times 8, I had started with 4 times 6? Well, let's try it and see. The factors of 4 are 2 and 2, both prime, so I'll circle those. And the factors of 6 are 2 and 3, and those are both prime, and I'll circle those. You'll notice I got exactly the same answer. It doesn't matter where we start. Okay, let's look at another example. Find the prime factors of 220. Well, 220 is 22 times 10, and 22 is 2 times 11. Those are both prime. And 10 is 2 and 5. Those are both primes. So our prime factors are 2 times 2 times 5 times 11, or 2 squared times 5 times 11. One last example. Let's find the prime factorization of 256. It's even, so I know 2 will go into it. So 2 times 128 is 256. So I'm going to start there. 128, I can see 4 goes into that easily. So that's 4 times 32. And 4 can be broken down into 2 times 2. And 32 is 4 times 8. Again, I'm going to break my 4 down into 2 times 2. And I'll break my 8 down into 2 times 4. And I'll break the 4 down into 2 times 2. Wow, I'm getting a lot of 2's there. When I prime factorize, I get 2 times 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 2. Or 2 to the 8th. In this case, the exponential form is much easier to read and understand. I'm often surprised by how often I end up using prime factorization, and specifically factor trees, when I'm trying to solve a problem or find a pattern among different numbers. So, go and have fun playing with this skill